Okay, so section 1.7 on linear models and scatter plots. I don't think it's going to be that challenging for you, and it's a lot of review from Algebra 2 and Algebra 1, and we've only got about 4 questions in the homework on it, so it shouldn't be too bad. So what scatter plots are all about is fitting a line to data. So you're going to be given some data, and it's going to be all over the place on your coordinate plane. It's it doesn't follow a pattern. It's more like real life of what you would find if you were solving a real life, say, engineering problem. And you want to find a line, an equation of a line that fits to that data so that you can make predictions about what's going to happen in the future for whatever that real life situation is. So I'm just going to fill in the blanks here a little bit, and then we really just want to get to the examples where you can see how to do those in your calculator. So many real life situations involve finding relationships between two variables. If data are collected and written as a set of ordered pairs, the graph of such a set is called a scatter plot. For a collection of ordered pairs in the form x, y, if y tends to increase as x increases, then the collection is said to have a positive correlation. If y tends to decrease as x increases, then the collection is said to have a negative correlation. So there's a few things I want you to see here. If you had to create a scatter plot that had a positive correlation, so positive means as one variable increases, the other one increases. So I'm just going to make up a situation here, like as the number of donuts that you eat, and then we're going to compare a person's weight. So if they eat very few donuts, their weight is very low. But as the number of donuts that they eat increases, so say here I've got a bigger number of donuts, say 10 donuts in a week, well then their weight is going to be higher as well. So as the number of donuts increases, the weight increases. That is a positive correlation. And then we want to try and think of a situation where something might have a negative correlation. And what that means is, as you can see, the dots in our positive correlation scenario went upward and to the right. So the number of dots for our negative correlation are going to start high. So while you have close to 0 of something, then you have a high number. So let's think of an example. Say, alright, so we're going to look at a correlation between the hours that you watch Netflix and your grade in pre-calculus. So if you watch very little Netflix, your grade is going to be up here as one of the highest grades. But as you start binging and watching Stranger Things and watching all the different series you guys like to watch, as you watch more and more hours of Netflix, look what happens to your pre-calculus grade. It goes down. So we say that has a negative correlation. It doesn't mean they're not related. It just means as one goes up, the other goes down. And then fitting a line to the data, what you're going to want to do is, if you just have to do this by hand, you're going to want to make the best estimate of a line that you can. That's with the same number of dots above it as are below it. So wherever you put that line, then you're going to find the intercept and the slope, and you can write the equation of that line. That's fitting a line to data. But we are going to fit a line to data that's given in a table, and we're going to do that in a different way using the calculator. So And then last but not least, to measure how well a linear model fits the data used to find the model, you're going to want to use the correlation coefficient. That's the R value, or the correlation coefficient. And so a high correlation coefficient would be a 1, and that means it has perfect positive correlation. And then a -1 would be a perfect negative correlation. And then if the correlation coefficient is 0, that means the two items of data, no correlation. Okay, so the correlation coefficient R of a set of data varies between 1 and -1. The closer the absolute value of R is to 1, the better the correlation. So for our example, we want to look at these numbers. The number of U.S. Navy personnel, P in thousands, on active duty for the years 2002 through 2006 are shown in the table. Use regression to find a linear model for the data. So here we have data, and so we're going to use our calculator. So T equals 2 corresponds to 2002. So that's year 2, year 3, year 4, year 5, year 6. And to put in the data, I'm going to go into my stat menu. I want to edit, and all these different lists in here, you can compare up to 6 items of data. So for my list 1, I'm going to make that be the years, because those are the independent coefficients. So I just enter in 2, 3, 4, 5, 6. And then for list 2, and that's my second set of data, I'm going to look at these P values here for the number of personnel per year. So we've got 383, 381, 376, 364, and 353. So I've got some mistakes in here. 364. Do I have 380? What in the world? 376. $364. Okay, so we've got our data in here. Now we need to do a linear regression. So we are going to do second calc, and we are going to go to so in the calculator we want to go to stat, and then we want to go to calc, and we want to look at option number 4, the linear regression. And let's see what's wrong here. So I'm going to go in stat, and I'm going to go into my list that I'm editing. And it looks like my lists are not the same length long. So 2, 3, 4, 5, 6. And then I've got okay, so in the year 2002, we had 383 bushels. We had 381. What did I just do? Oh, that's right. Okay, and here we had 2000, no. So that would be the year 2. Okay, but that's not what goes in there. We'd go 383. Okay, sorry. So we've got 383, 381, 376, 364, 353. So why is this wrong? $383, $381, $376, $364, $353. Okay, I'm so sorry about that. I was just kind of drifting off there during that problem. So what you want to do is a linear regression, which I've got mine pulled up here. So let me go through and show you how to do it. You go back into stats, and under the calc, you choose linreg ax plus b. So we're looking for a linear equation. Then you're going to get this standard report back. So if a is negative 7.7, your final answer is going to be negative 7.7 x squared plus 402.2x. And then you're given an r value and an r squared value. So r is the one I really care about. It's negative 0.961. That's pretty close to 1, so that means you have a pretty strong correlation factor, except it's close to negative 1, so it's a really strong negative correlation. So while one goes up, the other one goes down. So that's how you use your calculator for one of those. You're going to practice it a few more times on your homework, and ask me if you have any questions. Thanks.